Now we're looking at solving exponent questions, solving exponent equations, where we're going to be required to use a logarithm. Now we have been solving with exponents for quite a long time, where we had maybe x squared equals 16. Okay, well there's an exponent, we need to get rid of it, so we can just square root both sides. But what we haven't done is swap the x and the 2. Put the 2 here and the x there. So that is what's new, and that's what requires a logarithm. You can log the left side, you can log the right side, and then this can come down and turn to a multiply. Now this section is different than what we just did, which was solving log equations. So these equations all had logarithms in it, and we use them as exponents to kind of solve and find the x's. Here's backwards. Here we have exponents, and we're going to use the logarithms. So just start with a relatively simple one, that we're going to log the left and we're going to log the right. Okay, now we can do this. If we just log the left and log the right, well then this can come down. So we have x and then a log of 3 equals a log of 125. And then we can divide by log of 3 on both sides, because log of 3 is just a number. Remember, this is a 10 here, so this is 10 to the what gets me 3. I don't know what that is, but there is a number there, so it is possible. So those would cancel, and you would just have x equals log of 125 over log of 3. And then you could actually use a change of base formula, and you could actually put those together and say 125 and put the 3 there. And so that would be your answer. Now I'm actually going to do a slightly different way. And so this works for when you have a logarithm with only one x on one side. Then I would just do this. I would actually, instead of doing log base 10, I do log base 3. So what I do is I log base 3 both sides. I chose 3 because the x had the 3 there. So now I can bring this x down. So I've got an x times log base 3 of 3, and this side is log base 3 of 125. And then log base 3 of 3, this says 3 to the what gets me 3. We've done that a lot. The answer is just a 1, 3 to the 1. So this thing is just 1. It cancels out. In fact, we'd written, and you might want to write this somewhere up top, log base a of a is always 1. So this cancels out. And you just have x equals log base 3 of 125. The exact same answer, but there was no division necessary. So if you choose your bases carefully, then it just saves you a step. You don't have to do any conversion back to this form, and you don't have to do a division. So I'll pause this if you want to write this down. Okay, sorry, I won't pause it. Obviously you could pause it. I was just standing there doing nothing. Now, you could choose a log of both sides, because we need to get this x minus 4 down. So maybe I'll do this in a red here. So traditionally, people might have done this. Okay, we're going to do log both sides, e to the x minus 4, and 7. And they just choose log base 10, and we'll be done. So what I'd like to do is say, well, I'm just going to choose with this x minus 4, there's an e there, so I'll just do log base e on both sides. That way, when I bring this x minus 4 down, I'll be left with a log base e of e, and then that just cancels, because that would just be 1. So that's my goal. Now, unfortunately, log base e, we have to kind of remember we use the natural log. It's just got a different symbol. So we take the natural log of both sides. This x minus 4 can come down and turn to a multiply. So x minus 4 times. And I've got a ln of e, and I've got the natural log of 7. And of course, this ln of e, this is log base e of e, that's gone. So really this is just x minus 4 equals ln of 7. And then just some simple algebra, add the 4 to the other side. So I've got x equals ln of 7 plus 4. Now sometimes this seems kind of strange, so I brought up a calculator here. Well, let's see what this actually is approximate. So ln of 7, so the natural log of 7 plus 4. So 5.9459, 9459, approximately 9459. Yeah. Okay, so that's what our answer is. So apparently x, if I take this x and I throw it into here, e to the 5.9459 minus 4 should equal, I guess, the right side, which is 7. So just out of curiosity, let's try it. E. Now I'm actually going to use, I have all the decimal places here, so instead of going 5.9459, I'll do the rest too. 10149. So that is x minus 4. So minus 4. And hopefully this equals roughly 7. Oh, wow, look at that. Exactly 7. So yes, our answer is right. It just looks strange. These numbers look strange. Just like this number. Right here, log base 3, 125. I don't know what that is. And you could come up with a decimal approximation. So log of 125. Remember, if you don't have the log base formula, you can go log 125 over log 3. It's the same thing using the change of base. So 4.3949. I think I said that right. Yeah. So these are just numbers. If I went 3 to the power of, and you can try it, 3 to the power of 4.3949, and even put more decimal places in, it should be 125, or really, really close, because we've just got a decimal here, we've rounded, so our answer would be slightly, like really close to that, but slightly off. Okay, so let's try one more here. I don't know where this went. So here we go. So we're going to do, I see that this x has a 2 in front, so I'm going to do a log base 2 on both sides. You don't have to do it this way. If you learned some other way, you're more than welcome to do that. So I log base 2 of 2 minus 2 to the power of negative x, and log base 2 of 6. So now I can bring this negative x down below and turn it to a multiply. So negative x times, or you can put it in brackets maybe, negative x times log base 2 of 2 and log base 2 of 6. Now this log base 2 of 2 is just 1, that'll cancel out. So you just have negative x equals log base 2 of 6, which you can just divide by negative 1 or multiply by negative 1, doesn't matter. So x is equal to negative, I guess, log base 2 of 6. So there's a decimal approximation. I don't care about it though. We can just leave it like this. So those are the answers. In the next video, we will do the other 3 before things become slightly more complicated.